So hi, this is Henry, and today I'm gonna do a presentation about the polynomial function. And first, I'm gonna do a brief introduction to what are polynomial functions. So polynomial functions are only integer positive powers or zeros, and it is a function expressed in the form of polynomial, which is the name of polynomial functions. And the highest power is known as a degree. So for example, a cubic function. A cubic function's highest power is 3, so the degree of the function will be 3. Next is all the domain is all real numbers. Last, it is a bit different from rational functions. There are no asymptotes in polynomial functions. Next, I will talk briefly about the characteristics of the graphs in polynomial function. So first is degree and end behavior. So even degree is both ends decreases or increases at the same direction. But for odd degrees, the ends go in opposite directions. Second is the root, where the odd multiplicity crosses the x-axis and the even multiplicity touches the x-axis. Third is the turning points. So when the power of a function is n, so it has up to n minus 1 turning points where the graph changes direction is the turning points. And fourth is the intercepts. So x-intercepts are the roots, and y-intercepts are when f of 0. So fifth is the symmetry. When it's an even degree function, symmetry is at the y-axis. And when it's a odd degree function, there's a rotational symmetry at the origin. So the last is kind of similar to the third one. So the graph alternates between increasing and decreasing between the turning points. And now here are some examples and graphs of polynomial functions. So here are the constant function where there are only constant numbers, and there are linear function where there are by the power of 1, and there are quadratic function where there are the power of 2, and there are cubic function where they are the function of the power of 3, and there are a quadratic function where there is a power of 4. Now I'm gonna give some counter examples for the polynomial function. So these are not polynomial functions. First is when the power is negative. Here's an example. The example has a negative 9 for the power, so it cannot be a polynomial function. The second is when the power is a fraction. The power of the function is 1 out of 2, so it cannot be a polynomial function. And next is x cannot be in the power. For example, 2 cannot have a power of x. And next, x cannot be in the denominator. So it's also in the example. Here is a graph. Here is a step of graphing the functions. So first is identifying the degree, and the second is determining the end behavior by the coefficient of the function. Next is find the 0 by factoring the function, just like the example below, where I factoring the function and find the zeros of the function. And 4 is plot additional points to finish a graph and make it more detailed and fit the function. Now I'm gonna briefly introduce cubic function and quadratic function. first I would like to talk about cubic function. So it is a degree of 3 at most, and it often appears as the S shape, which is on the right, which is the graph. And it have up to 2 turning points and have exactly 1 inflection point. And it has 3 real roots because it has a degree of 3, and this is usually not symmetrical. So here is an example of the cubic function. I have listed some analysis of the function. So it has a root, and there are 2 turning points, and there are a inflection point at x equals 2, and there's the signature S shape for a cubic function. So now I'm gonna talk a little bit about quartic function. So it is a little bit different from cubic function. It has a degree of 4 at most, and it had up to 3 turning points, just like we mentioned, n minus 1, and it's up to 4 real roots, and it's x-intercepts, and it is usually symmetrical because it has a even number power. And next is y-intercept is the constant e, so when f of 0, it is e. It is similar to the point that we talked before. And here is an example of a quartic function. So it has a y-intercept of 0, 1, and x-intercept at 1, 0, and the vertex at 1, 0, and the symmetry at x equals 1. And it is a symmetrical function. Now I will give a real life connection to the functions. So the first come to my mind is roller coaster, which is connected to cubic function. So this is a graph of a roller coaster track, and here are some analysis of the graph. So there's a cubic term where it adds a steep rise and fall. So it is a characteristic of roller coaster drops. And there are a quadratic term which creates the parabolic shape for hills and valleys. And at last is the linear and constant terms, where it adjusts the position of the graph and also the slope of the track. And this is my citation of the presentation. And this is the end of my presentation.